Okay, so let's discuss the periodic table. The periodic table is the best cheat sheet ever invented. It has all these different areas. We've already gone through how there's a staircase that separates the nonmetals from the metals. There's different areas that we'll get into. These are the rare earth elements that kind of break off down here, transition metals in the middle. So it's very well organized, and we're going to get an appreciation for that during this unit. So across the periodic table, the rows, we call those periods. And the periods correspond to how many energy levels there are around the atoms. We discussed this when we were doing electrons. So the first row, the first period has one ring around it. The second period has two rings around it. Everything in the third period would have three rings around it. And that's how many rings of electrons there are. Those are the periods. Up and down, we call them groups. So this is group 1, group 2, group 3, 4, 5, 13, 14, 15. So there's some groups that have special names, and unfortunately, you need to learn some of these names. I've always hated when I was a youngster that I had to remember alkali metal family and alkali earth metal family. Thanks for that creativity. Plus, you probably never heard the word alkali before I just said it. So I tend to shy away from these. If you get deeper into chemistry, someone might ask you to memorize those. I don't like memorization in general, and those are not useful. Transition metals, unfortunately, is a very useful one, so you will need to memorize that. Transition metals, think about it though. There's a group up here that goes high, and then up here is high, and this is sort of the low one. So transition metals you should know. And then look at this. If we just did this, everyone would be happy. If you just called this the boron group because boron's on top, and the carbon group because carbon's on top, and the nitrogen group, see, those would have been great, and then no memorization would have been necessary. Unfortunately, before any of those were really kind of hashed out, they called these the halogens. Another one you're going to need to know. So halogens, transition metals you need to know, and of course noble gases, or as I call them, the Kardashians of the periodic table, the thing everything on the periodic table for some reason or other wants to be like. Okay, the history of the periodic table, again, not a lot of stuff here to memorize. You should know that Dmitry Mendeleev, well, you should know two things. One, that the periodic table is based on the number of protons. And two, that Dmitry Mendeleev almost figured that all out, except he figured it out because at the time all he could tell was atomic mass. So he organized it by reactivity and atomic mass. And the beautiful thing about this guy is he left blank spaces for the undiscovered elements. So you'll see here these two question marks for atomic mass of 68 and 70. He knew these weren't discovered yet based on the reactivity series that he had going, boron, aluminum. He knew something needed to be here, and he knew something needed to be here under silicon. He just knew, well, I guess we haven't figured those out yet. The other thing he figured out, which was pretty cool, and he has a little question mark here, that tellurium, even though it had a higher mass than iodine, belonged with selenium and sulfur because it reacted like those. And iodine reacted like other halogens, bromine, chlorine, fluorine. So even though their masses weren't putting them in the right place, he knew this is where the organization should be. So that's why I kind of give hats off to Mendeleev. He just didn't know that the reason this was happening was because of protons. Moseley was the one who figured that out. So he kind of punched it in after Dmitri took it 99 yards. Moseley punched it in. He was the one who figured out it's organized by protons. So you should know that the periodic table is organized both by protons and by reactivity. The valence electrons, we talked about this when we were doing electrons. They're the ones in the outermost shell. They're the first things that are encountered when another atom comes up. And because of that, they are very important to reactivity. So the reason why these things all had the same reactivity is because of their valence electrons. Fluorine, chlorine, bromine, iodine all have 7 valence electrons. So they all react the same. Oxygen, sulfur, selenium all have 6. Nitrogen, phosphorus, arsenic all have 5. Carbon, silicon, 4. So the reason why they were able to be put into these things is because they had the same number of valence electrons. And